I think it's entirely possible that OpenAI could hit 100 billion ARR in a couple of years. I think the easiest path is probably just taking agents and running them continuously 24/7. As long as they're generating sufficient economic value, I think it's not that difficult to imagine. I think it's not that difficult to imagine OpenAI tripling revenue year over year for the next 2.5 years, and getting there in 2027. The key, again, is just taking knowledge work and taking service economy and distilling that down to agents running 24/7. Yeah, no, remember, the internet was born here. The US has lots of available land. Hyperscalers are largely based here. We have access to capital. I don't think it's that surprising that number of data centers. Remember, this is not the number of AI data centers or the number of NeoCloud or Stargate type data centers. This is just total number of data centers would have a modality in the US. Almost certainly. Maybe we should cover that in the next episode.
Yeah, I couldn't find it. Well,
I'll take the other side of that, if I may. I mean, history tells us at any given time that the market values what's both scarce and needed. So we've seen multiple East India companies. We've seen various scarcities, including oil, pop up over the centuries. I would argue that this is actually just a market signal that right now compute is both scarce and needed, but the way the game of capitalism works is this value wants to diffuse over many companies and probably many countries over time. And that diffusion is going to be a net wealth creator.
Alex, divide by zero.
I will actually say, much as I'd love to tell a just so story that this marks the beginning of the decoupling of labor and capital, I think this is actually just garden variety changes in Federal Reserve interest rate hikes. In late 2022, as interest rates started to come back down, the market goes up. And as COVID starts to retreat, job openings and job displacements also start to return to 2021 levels. So again, I would love to tell a just so story. This is the beginning of decoupling of labor and capital, but I think that this might just be
I'll give you the opposite.
Yeah, I think it's difficult to buy. This seems to be an argument premised on what in the AI alignment research community is called the orthogonality thesis, that it's possible to have intelligent agents of arbitrarily high levels of capability that nonetheless can be directed to pursue any goal. In this case, it seems like Jeff is basically re-articulating the orthogonality thesis with perhaps a veneer of digital oxytocin, as you said, Peter. I think that's unlikely and probably not that robust a means of an alignment for superintelligence. I think if the goal is to have a more robust guarantee of intelligence, approaches that acknowledge instrumental convergence being the idea that no matter what your long-term goal is, you tend to have certain convergent common short-term goals. I think instrumental convergent type approaches are more likely to guarantee or provide robust guarantees of friendliness. So James Miller wrote, I think, an excellent essay called Reasons to Preserve Humanity on Less Wrong that enumerates couple dozen different reasons for why superintelligence should play nicely with humanity out of self-interest, not out of some sort of oxytocin-induced, surgically added reason that's sort of artificial. Yeah, I think in this case, if you look closely at the video, the lip syncing was poor. I think in the short term, detecting counterfeit.
You're part of the 24% that can notice this. Okay, Alex, you win on that.
Definitely noticed the poor lip syncing. I think like in the short term, detecting counterfeit live streams in real time doesn't seem like a terribly deep technical challenge. In the long term, we're going to have more solutions like ubiquitous watermarking, perhaps cryptographic guarantees of reality, perhaps. I don't think in the long term this is a deal killer for us drowning in AI-generated slop counterfeit live streams. I think this is very tractable. I'll throw in a comment. I want to reason by analogy. There's a process that those not steeped perhaps in semiconductor manufacturing may not be familiar with. It's called zone melting, and it's a process for purifying, not knowledge in this case, but purifying semiconductors. And the idea is you take a rod and you pass it through a heater. And because there are more ways for impurities to exist in the solid state, in the melted state, rather than in the solid state, the impurities migrate out of the solid into the liquid state, and you do this over and over again, you get a purer and purer semiconductor. We don't have a science right now for knowledge purification, but one could imagine somehow near future, we have a science for it, and we decide there are more ways for correct knowledge to be self-consistent than incorrect knowledge. And I think we're starting to see the beginnings of almost a knowledge equivalent of zone melting, where you take the raw slop, human slop of the internet, you pass it through multiple passes of AI gen synthesis, creating what aspirationally would be more correct versions of the ground truth. Do this over and over again, and maybe aspirationally, because there are more ways for the truth to be self-consistent than whatever the starting knowledge was, maybe we arrive at some sort of ground truth through this result. I don't know,
cool.
But it would be interesting if that ended up being the case.
Well, that is Elon. Alex, would you take us through it?
Sure. So there's an enormous cottage industry of AI researchers trying to define what intelligence even is. I've been guilty of that in past years as well. My bias has always been to look for a universal, elegant definition of what intelligence is that isn't necessarily grounded in human behavior or human psychology. This paper, and as Peter, you mentioned, we know a number of the co-authors on this paper. The basic idea behind this paper is to do the exact opposite. Instead of trying to look for some human agnostic definition of intelligence so that we can build more of it, the idea is instead to look at human psychology. So there is a theory that's popular in human psychology. It's called the Cattell-Horn-Carroll, or CHC theory, that decomposes human intelligence into 10 different factors, like the ability to reason quantitatively or to do visual processing. So the idea behind this paper is to define a benchmark that's directly inspired by the CHC theory to decompose intelligence of frontier models into 10 different categories with various subtasks associated with each category. And the main upshot of benchmarking GPT-4 and GPT-5 Auto, critically not GPT-5 Pro, according to my reading of the paper, the main upshot is, surprise, intelligence is jagged. The frontier models are stronger at some skills, weaker at other skills. Whereas the archetypical human would perhaps have a more uniform distribution of their skills across these 10 categories. But I would add the important caveat, again, just based on my reading of the paper, they didn't actually benchmark the bleeding edge frontier models like GPT-5 Pro.
It's all humans. I mean, no human is going to match 10 on this. Maybe
a quote-unquote well-educated adult. Yeah, but based on my read, the memory storage access corresponded, or the deficiencies thereof corresponded roughly to the fact that off-the-shelf vanilla language models and foundation models have a finite input context window. So if you ask them questions that reference older information, by default, unless there's some sort of compression or memory compactification or RAG type mechanism, they don't have the ability to remember things that you told them a long time ago. But again, I want to caveat this benchmark. I love benchmarks in general, as I mentioned previously on the pod, but these are off-the-shelf models without any agent bureaucracies on top of them, without prompt optimization, without even access to bleeding edge reasoning efforts. This is just, if you read the paper, it's just GPT-5 Auto. So I'm wary to put my finger on certain deficiencies as being in any way indicative or instructive of the limitations of AI.
Other models that would perform much better on these 10 parameters.
Or light modifications of existing models that, as with RAG, retrieval augmented generation, make them superb at certain skills. So I think that where this is useful in my mind is just having yet another benchmark as a proxy. It's a start, an important start for measuring human capabilities against AI capabilities. But when I see 57%, we've talked in the past on the pod about, in the style of Ray Kurzweil, the moment you've passed 10% or maybe even less, you're basically halfway there. Getting 57% on a general human psychological benchmark, that indicates to me that probably with a little bit of reinforcement learning, a little bit of bureaucracy, agents, frameworks, scaffolding, you probably get to 90% today.
Okay.
I'd like to point out maybe quickly two possible
Alex.
societal goods here. One is that this results in one of the world's largest nonprofits being created that now has the backing of a frontier lab. And the stated goal of the new OpenAI nonprofit, one of their first goals is to spend $25 billion using AI to solve disease. And I think that's a tremendous societal good. We've spoken here in the past about how AI has the potential to solve disease and biology in the next 5 years. I think this is another arrow in the quiver of making that happen. Second societal good, one of the things I worry about is what happens if a private frontier lab develops incredible superintelligence and decouples from the human economy. I think putting OpenAI on a trajectory where it can reasonably be expected to go public sometime in the next 2 to 3 years, I think an IPO by OpenAI and other frontier labs and putting the equity in the hands of retail investors and index funds is almost certainly a net societal good because it keeps the economic interests of large chunks of humanity aligned with these frontier labs and vice versa.
Alex,
I think it's actually like a pretty tiny number. The global GDP is upwards of 100 trillion. So just saying we're going to spend 1% of global GDP on AI infrastructure.
Yeah, but this is one. Yeah, but this is one guy, Alex.
It's one company.
One company, right?
Yeah.
Okay, so
incredible.
So if you have like 5 frontier labs each doing that's still like 5% of global GDP. I think this is a drop in the bucket, and that's before AI starts to radically grow the global economy. This feels on the low end to me. It's a really interesting paper. You'll recall that historically the best suggestion that was floating around the AI research community for diagnosing self-awareness was maybe you train a model on the internet excluding any notion or any mention of self-awareness and see whether the model is then able to articulate something about self-awareness. I think that original proposal was probably somewhat impractical. This is a far more practical diagnostic for self-awareness. And the idea is basically take the internal hidden activations of a model and graft on an external thought, sort of incepting an externally imposed thought onto a model and detecting whether a model is able to recognize that it's having external thoughts intrude upon its internal activations. And
isn't that called psychosis?
I think that might be slightly different. I think this is closer to some sort of maybe telepathic forcing. Uh-huh. You're taking an external activation vector and forcing it upon the internal hidden activations of the model, and then checking whether the model realizes that it's being externally influenced. And pretty remarkably, some of their stronger models, the Opus 4, 4.1, were about 20% of the time able to articulate not only that they were being externally influenced through this sort of vector activation injection, but were also able to reasonably well articulate precisely the nature of the external thought that was being forced into their internal streams.
So the question is, Alex,
the proposal in this paper is that self-awareness means that the model is able to think about its own thought. Mm-hmm. It's able to understand what its own inner thoughts, if you will, its own inner activations are, and able to reason based on that. Just to comment, Peter, on this as well, I think the elephant in the room here is that the visual ads that are being generated are not being generated pixel by pixel. I've spoken on the pod in the past about how in the future user interfaces, I think are just going to be every pixel is purely generative. In this case, it's almost charmingly retro in the sense that it's not pixel by pixel generated. It's vector graphics. It's images and photos clipped from the original underlying website. And I think the elephant in the room that it's not purely generative means that it's going to be ultra low compute cost to generate. And that is suggestive that we may live in a very near-term future where display ads on the internet are generated on demand because it's relatively compute expensive at the moment to generate a custom image pixel by pixel for an ad, but it's relatively lightweight.
I love that.
Yeah. Yeah, I used it. It was a fantastic experience, and I think somewhat differentiated from the vibe coding, the in-browser vibe coding experiences from OpenAI or Anthropic. For one, it creates multiple files. If you ask it to create an app, it's not just sort of fixated on a single self-contained file, so it can create multiple files of code, which is very important for certain sorts of apps. So I ran it, of course, through my favorite eval for vibe coding, which is create a visually stunning cyberpunk first-person shooter. And it created a visually stunning dashboard, sort of an intro lobby dashboard for the FPS, but I had to prompt it to create the rest of the game. But it was what it did create was visually stunning, and I think it's a promising first step.
Alex, what do you make of this one?
This is what recursive self-improvement looks like, Peter. This is GPUs, AI being used to optimize chips to make more AI. And there are so many applications ranging from computational lithography to fab optimization for this. I think when I've spoken in past of the innermost loop of civilization looking like some linear combination of chips, robots, data centers, power sources, all of these, this is what the innermost loop of civilization spinning faster and faster looks like. Also, I read Gil's paper, and I'm a huge fan in general of trying to get closer and closer to the physical limits of computing. Seth Lloyd famously 20 plus years ago discovered/reported that the ultimate physical computer would probably, at least for serial computing, look like a black hole as the ultimate supercomputer. So I'm a big fan of approaching the physical limits of computing. In this case, though, my worry is there's such a sort of a sordid history of probabilistic computing approaches being attempted and failing to keep up with Moore's law and algorithmic improvements. This is my worry. I want to believe, I want something like this to succeed, but I'm not super optimistic that this isn't just going to get steamrolled by algorithmic advances and advances in good old-fashioned CMOS digital logic. It looks too much like analog computing, probabilistic computing. And remember, 10,000 times, even generously, 10,000 times energy improvement at the rate that models and algorithms are advancing and the rate that good old-fashioned digital CMOS is improving, that may only be a few years of headroom, which a new architecture would need anyway to get off the ground. In principle, yes, but in practice, the workloads that the economy demands have to be able to run on these computers in order for you to realize this hypothetical energy advantage. And I think for better or for worse, the burden of proof is on Extropic and Gil to demonstrate that his hardware can host workloads that are as commercially valuable as, say, it turns out that just for a second. Black holes are wonderful computers. They'd be a little bit difficult on the input-output side, especially the output side. A little. Input-output side, especially the output side. A little. But in principle, so you can, and Seth and others have refined this notion, you can define a generalized notion of computation and then in pure physics. So it deals with terms of how quickly can internal state changes happen inside a physical system. And turns out black holes are absolutely the physical limit based on the physics that we have today for the fastest serial computer, because state changes in terms of their quantum state evolve at the physical limit. So programming them may be a little bit challenging. Maybe you'd have to fire in like an X-ray laser or gamma ray laser, and maybe you have to parse the Hawking radiation. Yes. But if you can solve input-output, black hole supercomputer is the way to go.
Dyson swarms,
let's talk
brains.
about what we're talking about. We're talking about disassembling the moon to build more computers, to build Computronium and the Dyson swarm. And what's more remarkable, I mean, just in the past few episodes of the pod, I've been beating the drum for how, mark your calendar now, we're at the very beginning of the construction of the Dyson swarm. Yes. Maybe I was overly pessimistic. Maybe we're actually going to see multiple competing Dyson swarms, and SpaceX is going to launch one. You'll see other companies, maybe other frontier labs, launch competing Dyson swarms. At this point, in the style of worrying about overpopulation on Mars, I'm starting to wonder whether I should be instead banging the drum for ensuring good interoperability between all of the Dyson swarms. Yeah, so these are three overlapping concepts. So Dyson sphere, Dyson swarm, Matryoshka brain. Dyson sphere was this notion of having basically, and there was even a Star Trek Next Generation episode that depicted this, yes. A solid sphere at roughly Earth radius from the sun that lots of people perhaps could live on the interior of and enjoy nice environments and things. Probably not practical from a material science perspective. The stresses would be enormous. The stresses would be enormous. That's Dyson sphere. Dyson swarm says, let's, rather than having this be a solid enclosure that's rigid, let's instead have this be lots of orbiting satellites that are nonetheless collecting the energy from the sun. Matryoshka brain says, let's take multiple Dyson spheres at different radii from the sun and have the innermost spheres consume the light, the solar insolation at certain frequencies, and then radiate waste heat outward to the outermost spheres, which then will consume progressively more and more infrared shifted radiation and use that to power their compute. So these three concepts, Dyson sphere, Dyson swarm, and Matryoshka brain, and also Jupiter brain is another popular depiction. These are all interrelated concepts. I think if we go the trajectory of taking apart our solar system, whether we brand it as one or the other, they're pretty similar. Whether we brand it as one or the other, they're pretty similar.
And Matryoshka brain just...
You know, I wonder about this. Like, if this is the fate of intelligent civilizations, I would expect to see more infrared shifted solar systems elsewhere in the galaxy. To my knowledge, we haven't observed this. That makes me suspicious that even though I bang the drum for Dyson swarms, maybe there's something out there lurking in our technological future that will cause us to not actually need to take apart our solar system.
That's ridiculous.
There's something there.
I'll point out also, just for California specifically, if folks are familiar with the infamous so-called duck curve of California, where the demand for electricity peaks in the evening, like right after sunset, and also in the morning, there is a mismatch between California, which is rich in insolation, in solar energy on the one hand, and the need for early evening power. I think even just a few hours of battery storage can help to smooth out the duck curve, and that's transformative for California in a way that we here, perhaps in New England, don't have quite the same problem. This is huge. Like,
this is great. This
is huge. Like,
this is great.
Yeah, this is an important bridge, I think, to the near future.
I think
Well, I think bridges are important. Right now, the limiting factor for tiling the world with compute is, as a number of executives have recently pointed out, we have the GPUs. The problem is having warm racks to put them in, as Satya Nadella said in the past few days.
I saw.
Yeah. Mm-hmm. So I think, like, having bridges, like reactivating otherwise disused nuclear plants, I think this is an incredibly important bridge to the future until we get SMRs and fusion and maybe solar and maybe new forms of nat gas.
Totally,
we need
totally
the bridge.
right. And
in the entire world around us.
That's right.
Alex, what's your take?
I've spoken in past about how this innermost loop is not going to remain contained inside data centers for very long. I think, as I've noted in past, the compute is literally going to walk out the door of the data centers. In this case, it's going to drive out the door. But I think for many people, these driverless cars, I have one, and many people I know, surprisingly, haven't even driven in one or haven't had the experience of driving in one. For many people, this is going to be their first encounter with a generalist robot. It's going to be either seeing or driving in or owning a driverless car. And it's not going to stop there. I think the same stack that we're seeing NVIDIA with their autonomous vehicles pushing, it's going to generalize to humanoid robots on the timescale of 1 to 3 years. So this is, again, the beginning of the expanded innermost loop of civilization that we're seeing.
Loop, isn't it, Alex?
It is. This is robots operating factories that make servers that go in data centers that power the robots. That's the loop. I also think that this is a preview of how we get. I also think that this is a preview of how we get. You know, you were talking earlier, Peter, about Sam's forecast of a gigawatt per week. I think that this is a plausible technical trajectory for how we get there. We're going to have robots building the fabs and the factories producing the servers and the data centers. It's going to be one massive flywheel. Yeah, I pre-ordered mine. Can't wait to have the experience. I do think it's interesting that in many of the scenarios for the Neo, at least in the early days, according to 1X, they're going to be teleoperated, and that may turn some people off. Having someone tele-remote into their home doesn't bother me at all. I'm very, very excited to try this out.
They can get it out the door at $20K.
Yeah,
if I were running this company, I'd be subsidizing. I mean, this is a data collection play to get a huge VLA trade-in set. Yeah. And it's training people to expect price points that resemble, if you're purchasing it outright, a cheap car. And if you're leasing it, it's like leasing a car. This will be, I've mentioned in past the American dream, so-called, of having house in the suburbs, a car, and now a humanoid robot. Doesn't necessarily generalize that well to the rest of the world, but I think having at least one humanoid robot in your home becomes part of the new economy. We're going to get nanobots, I think, that will enable us to regulate ecosystems. And I think in the process, it's probably going to raise a number of bioethical questions. Peter, you and I and Dave have talked offline about near-term futures where, for bioethical reasons, or maybe even, dare I say, effective altruistic reasons, we're repairing butterfly wings on the one hand, but on the other hand, we have drones to obliterate mosquito populations. It's going to be a very interesting future.
Thinking for what I would be talking about today. So that's just
Well, we're trying.
What about putting a black hole supercomputer on every desktop in every home?